So working with the NRDs and NDEE, we surveyed irrigation water, the well water, and we're most interested in how much are we getting agronomically in terms of essential nutrients, lime, and also some other properties. So with essential nutrients, the plants require carbon, hydrogen, oxygen, phosphorus, potassium, nitrogen, sulfur, calcium, iron, magnesium, boron, manganese, copper, zinc, molybdenum, chloride, and nickel. And we used to say C. Hopkins Cafe, managed by my cousin Mo. But since then, it's been verified that chloride and nickel are essential. So I guess we could add something like Clooney there. Carbon, hydrogen, and oxygen come from water and or air, and all the others come from the soil. So we looked at all these nutrients from the soil with the exception of nickel, and we looked at lime and we looked at other problems. Just to highlight statewide, so there are 642 wells sampled, 32 from Lower Republican, 55 from Tri-Basin, and I appreciate that Tri-Basin paid for the analysis of some of these samples. One way we present the results is how much is applied in 10 acre inches and how much is that relative to the removal in 200 bushels of corn. So it gives us a sense of the balance that's affected, the nutrient balance and how it's affected by irrigation. It doesn't tell us whether we need to put on nutrients or not, although if we're putting on well above what we're removing, it's very probable we do not have to be applying. So statewide, 100% of the wells supplied sufficient calcium and chloride, 93% of the wells for magnesium, 73% for sulfur, 20% for potassium, 16 for manganese or molybdenum, 7% for boron, and just a few for zinc, copper, iron, but none for phosphorus. 70% of the wells had a liming effect with 10 acre inches, sufficient to neutralize the acidification that we give with 200 pounds of fertilizer nitrogen. Most wells have below 4.4 parts per million nitrate nitrogen, but 25% were above. And again, this is statewide. And there's relatively low nutrient supply and lime supply in the sandhills, but often it's high for wells less than 100 feet, but we'll see that's not consistent. So one way we look at the wells is by categories, 11 different categories based on the aquifer, the geology, and the depth. So we have two categories here of less than 100 feet. TO, that would be in the Ogallala geological formation, and the others are in other formations. The yellow is indicating the Sandhills wells. If we look at Tri-Basin, most of them are this color green, which is HP, High Plains Aquifer. TO stands for the Ogallala geological formation. We get to Lower Republic and we see some different colors. The northern part, yes, it's still primarily the Ogallala formation, but we get more of these pink colors and what do you want to call it, beige maybe. The pink is from an older formation, which would be underlying or if the Ogallala is present, but the Niobrara formation. And then the shallower wells indicated by this brownish or beige color are also in that older geological formation. So it's interesting to compare these because of the different geological backgrounds. And looking at them more closely here, Tri-Basin and Lower Republic, The red color is also of an older period, Cretaceous period that precedes the Ogallala. Much of our data is presented in whisker box diagrams, as you see here. So in the figures I'll be showing, we have the NRDs listed along the bottom axis, and then on the left-hand axis would be the values for whatever the property is that we're looking at. 50% of the observations, intermediate observations, fall in the box. 25% are either above or below, represented by the whiskers. X is the average. The bar across the box is the median. That is 50% of the values are above, 50% of the values are below. And the circles represent outliers. Statistically, they're not expected for the NRD, but they are real measured values. So here we're looking at well depth, and the color code is for whether it's central, blue color, eastern, orange, or green for western part of the state. We're focusing on LR, the lower Republican, and Tri-Basin. And we see on average your depths are near average. But if we look at the map here, we have a lot of yellow, a lot of wells less than 100 foot or 103 feet deep. These are along the river valleys, the Platte and the lower Republican. The black dots are greater than 323 feet. So you have quite a mix of depths, but not so deep as on average as some of the other NRDs. For nitrate, we have pounds here with the range going up to 100 pounds applied in 10 acre inches. And we see in one value at 90 pounds. Looking at the lower Republican and the Tri-Basin, here the average is about 10 pounds. No, not the average, the median. About 50% of the values are less than 10 pounds applied per 10 acre inches. And with the Tri-Basin, it's somewhat higher. We see that also in the distribution of the points, more dark colors with Tri-Basin and lower Republican. Some wells less than 1.3 parts per million. Sorry. And others above 11.5 parts per million, but indicated by the black. To summarize, for lower Republican, the shallower wells, that is less than 100 feet compared to deeper than 100 feet, there was not much difference. And the median value was 4 parts per million, 50% above 4, 50% below, but 34% had greater than 10 parts per million nitrate nitrogen. For Tri-Basin, it was interesting to separate the deeper from the lower wells. We see with shallower wells, that the median was much higher, 21.6 parts per million, and 86% of the wells were had more than 10 parts per million. And it's indicated here by these black dots. Whereas for wells deeper than 100 feet, the median was only 6.6 and just 37% had high nitrate concentrations. It should bring you up to this green box here at the top. To convert parts per million to pounds applied in 10 acre inches, we simply multiplied parts per million by 2.265. With phosphorus, zinc, iron, and copper, we do not have much applied. The range here with phosphorus only goes up to showing on my screen here. I'm not sure how to do that. Should after all this time, I guess, but I don't. We don't get anywhere near the amount of phosphorus applied as we remove and harvest. With zinc, typically we remove about 0.17 pounds in 200 bushels of corn. So if we look across here at about 0.17 and we look at the lower Republican, it looks like all the wells are below that. And with Tri-Basin also. So generally with phosphorus, zinc, iron here, copper, you do not get much supply. The manganese, molybdenum, it's a bit of a different story. Still, most wells do not apply enough, but here with the lower Republican, we see, some that are going quite high for manganese and also for molybdenum. And also, with the Tri-Basin for molybdenum. Boron, some supply, but not a lot. A few wells supplying more than is removed in the harvest, more than 3.37. With chloride, we get lots of supply. Note that here our y-axis is going up to 250 pounds per 10 acre inches, while we remove very little in grain. It is an essential nutrient, but in grain we remove very little. So all of the wells are supplying across the state, supply sufficient chloride. So here we're looking at percent of wells that in 10 acre inches supply more than is removed in 200 bushels of harvest. And here again, depth becomes important for the lower Republican at least. So if the wells are less than 100 feet deep, 73% of the wells supplied sufficient, well, 0% of the deep wells did supplied sufficient. And with the Tri-Basin, it's the other way around. That is, there's 0% of the wells of less than 100 feet that supply much manganese, whereas 21% did. So maybe you have some local knowledge of the geology in the wells there that I don't know. If if you can give me feedback later sometime on this, I'd be grateful. Molybdenum also we see with the shallower wells in lower Republican that you get more supply than with the deeper wells. And again, with the Tri-Basin, it tends to be different, although the difference is not so much, but more supply again with the deeper wells. With boron, it ranges from 0 to 6% of the wells. And, where we do get some supply, it's with the deeper wells and not with the shallower wells. Potassium, a great interest. Looking at the map, we see a lot of dark points in Tri-Basin and also in lower Republican. We look over here, we see, okay, about 28.4 pounds removed in 200 bushels of corn. So going across here, we see probably not 50%, but a good proportion of the wells are putting on more than 10 acre inches. And with Tri-Basin also, it's close to 50% of the wells that supply enough potassium in 10 acre inches to keep the balance. Looking at this more closely, more than 28.4 pounds of potassium are applied in 10 acre inches for 91% of the wells in lower Republican that are less than 100 feet deep, but only 19% for the deeper wells. And with Tri-Basin, the depth doesn't make so much difference, but we have 43% for the shallower and 50% for the deeper. So some good economic value there with the potassium being supplied. If you're putting on more than 28.4 inches, you should be holding your soil test values. or increasing them. Calcium and magnesium distributions are highly correlated. Here we're looking at the results for calcium. We don't have much removal of calcium, just 2.6 pounds and 200 bushels of grain. It's more actually for magnesium, between 9 and 10. We see that for lower Republican, you're getting well above that. Your average is like 250, or your median is like 250 pounds in 10 acre inches. And for Tri-Basin, also close to 300, 280 maybe. So a lot of dark points indicating this. So all of the wells in the two NRDs supply enough in 10 acre inches to exceed what's removed in 200 bushels of corn. Sulfur of great interest. Let's look at the results first. So 13.6 pounds typically removed in 200 bushels of corn. Here your median for lower Republican is what, about 40 maybe. Tri-Basin well above that, well above 100, close to 150 pounds. So you're getting a lot of sulfur application with most wells. But you do see some yellow points here and some light green. Most of the green would be supplying enough. The yellow ones do not. So 91% of the wells in the lower Republican of less than 100 feet, and 95% for the deeper wells supply more than 13.6 pounds of sulfur in 10 acre inches, and a very high percentage as well for the Tri-Basin, both for the deeper and the shallower wells. And those that don't are probably these yellow points that we see. We get a liming effect with irrigation water. It's due to bicarbonate in the water, not carbonate. Actually, the carbonate levels were very low. If it was present, that would be contributing to the liming effect. So we see on our axis here, the ag lime equivalent is ranging up to 3,000 pounds applied. Now, to interpret this, consider it takes about 340 pounds of ag lime, again, 60% effective, to neutralize the acidification of 200 pounds of fertilizer nitrogen. Looking at the lower Republican, we see lots over 1,000 pounds applied of ag lime equivalent in 10 acre inches, and also at Tri-Basin for most of our wells. High liming effect with all the lower Republican wells, a few that were less than 100 feet did not supply sufficient, such as with this yellow point here. But it was interesting with the Tri-Basin, the shallower Tri-Basin wells, many of them did not supply much liming effect. It'll be interesting to know why that might be. But we see them, some of those here with the yellow points. Whereas with the deeper wells, 95% were putting on enough liming effect to neutralize acidification. Now, of course, if you're applying more water, then you're getting more effect. If you apply less, as would be the case in southeastern Nebraska, the supply would be less than indicated. Let me go back to sulfur. Sulfur, chloride, and boron are all three negatively charged. So they're easily leached. If you apply any of these to the soil in the spring, there is potential for leaching loss. More, of course, with the sandy soils than what you typically have in your NRDs. With the irrigation, you're putting the nutrients on as the crop needs them mostly. And so we expect much better efficiency of use, much better recovery than if we would soil apply these nutrients. Sodium is not required by the crops for crop growth. It's not an essential nutrient. But it is important to us if we get too much sodium in the soil, it causes the soil aggregates to break down. And for the soil to be slick when it's wet, hard when it's dry, and the water infiltration is reduced. And by applying a lot of sodium in irrigation water, there's the danger of raising the soil sodium levels to have problems. When we evaluate sodium, we don't look at sodium alone, but we look at it relative to the concentration of calcium and magnesium. And this gives us the sodium absorption ratio, or the SAR. With your NRDs, although there is a high value here of sodium for the lower Republican, we don't see such extreme values for the SAR. All of your wells tested out okay. No threats indicated due to high sodium. Electrical conductivity is a measure of the total dissolved salts in the water. And it's not just sodium chloride, but all your salts. And so if you have high calcium, magnesium, these contribute to the salt effect. So it's a measure of the salt content and the salinity of the water. Some of our crops, including corn, is quite sensitive to high salt. Corn's much more sensitive than soybean or wheat or sorghum and most of our other agronomic crops. Dry bean is another crop that's very sensitive. So there is there is a bit high here, above 2 for one of the wells in Lower Republican. And the Tri-Basin indicates here, the whisker, that there might be some high values. But these are not high enough to be problematic. So none of the sampled wells had problematic levels of SAR or salinity. The top 2 images are for alkalinity and total hardness of the water. Now, they're very similar. They're correlated. You see the values are somewhat different and the maps are different. For instance, here in Tri-Basin with alkalinity, we have some yellow points, which do not, they show up as green and for the hardness. Alkalinity is calculated from the bicarbonate level of the water, whereas total hardness is calculated primarily from calcium, magnesium concentrations. So again, they're different, but they're quite highly correlated. And then we have pH, and pH varies quite considerably, independent of other properties, independent of bicarbonate concentration or total hardness, etc. We do not see any, you got some dark points here, but these are not problematic levels. And although they could be with some chemigation. And I really don't know that much about it, but some of the chemicals can react with the hardness to reduce effectiveness, or the hardness also can lead to deposits that could plug, especially our emitters with drip irrigation. With pH, if you have high pH and high iron content, also you could get some deposits. So those, would be potential problems associated with these traits. Again, there are some differences with well depth. And these different effects, depth effects, were not consistent across NRDs. So we have, for alkalinity and hardness, we have 336 and 408 with wells less than 100 feet deep in Lower Republican, and somewhat lower levels for the deeper wells. Whereas with Tri-Basin, the shallower wells had the lower levels than the deeper wells. So again, it'd be nice to know what the reasons are. I assume it has to do with the different geology, where with Tri-Basin, the wells are primarily in the Ogallala, at least with the deeper wells, and versus in the Niobrara Formation for the lower Republican, at least some of them. So to summarize, for your NRDs, irrigation supply in 10-acre inches was greater than removal in 200 bushels of corn grain for calcium and magnesium and chloride for all of your sampled wells. It was for 96% of the wells for sulfur, potassium 48%, manganese 21%, molybdenum 47%. And again, the well depth and NRD had any effect on these. Not much supply of boron, zinc, copper, iron, although at boron it was probably enough to help maintain your soil test levels, to delay the time when you might have to apply boron to have high yields. Liming neutralizes acidification by 200 pounds of fertilizer nitrogen for 91% of the wells. Most of the wells across the two NRDs were at less than 6.9 parts per million nitrate nitrogen, but 40% were above 10 parts per million. Nutrient and lime supply for wells of less than 100 feet compared with the deeper wells was generally greater for lower Republican, but we tend to see the opposite for Tri-Basin, the exception being nitrate, where the nitrate nitrogen was much higher with the shallower wells in Tri-Basin. Sodium, salinity and sodium of little concern. You saw that there was variations out there. There are patterns, but there's also variation within short distances. Therefore, to really take advantage of what the irrigation water is supplying, it would be good that, individual wells, all of them be tested, or at least groups of similar wells. And this doesn't have to be done very often. It might be enough to do it once in 15 years. The cost for the complete test that we had would be about $50 unless the NRD negotiated a special fee. We paid a bit less than $30 for this study. But you might go with another analysis that measures fewer properties, and it'd be under $30 in that case. So we suggest using the water information together with soil test information to decide on fertilizer and lime use according to the University of Nebraska guidelines. There should be an extension circular coming out reporting on this in detail with maps for all the properties. I only showed some of the maps and diagrams for some of the properties, not all of them. But in the extension circular, this will be fully covered. The data set is also freely available. It's online. Anyone who's interested, I can send you this link and you can download it. I do encourage the NRDs, if you have producers that do test wells, that you try to add the data to the database, and we gradually build up the database to have it more complete. Thank you for this opportunity. I think there's some time for questions or comments.
Yes, are there questions for Dr. Wortmann about his work?